welcome to the next chapter, chapter 7C, study of compounds nitric acid. Okay, today is the first day of myself teaching you the chapter nitric acid. Today is 29th of July 2021. Now, tell me somebody, what is the formula of sulfuric acid? What is the formula
H2S.
for
SO4.
H2SO4?
H2SO.
Sulfuric acid, the
H2S.
formula is H2SO4. What is the formula of hydrochloric acid?
HCl.
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 The formula of hydrochloric acid is HCl, okay? And the formula of nitric acid is here, HNO3. Now, please note that these three acids, hydrochloric acid, nitric acid, and sulfuric acid, are the three most important inorganic acids. Inorganic acids in our syllabus, okay? The syllabus is ours. So these are the three most important acids in our syllabus. Okay, now I will just move ahead to the next slide where you just watch the video and listen to my audio. Okay, watch to the video and listen to what? To my audio, myself speaking. Okay, am I clear? Now have a look at it. I will speak. You just watch the video and listen to what I speak. Okay. So on your screen, now you'll be able to see how nitric acid is prepared from air. Okay. Now just have a look. Have some patience.
All right, everyone. Cody Don here. So today I'll be showing you how to make nitric acid using
Nitric acid preparation
electricity,
using
air,
electricity,
and
air,
water.
and water. Okay. This guy is
I'm
showing
going to
us.
be using the same process
So,
that forms nitric acid
he's-
naturally, like in
he's,
lightning.
what do you
Electricity,
call-
or an incredibly high temperature, breaks apart.
He is using nitrogen gas and oxygen gas from the air to prepare nitric oxide, oxygen, and then prepare nitrogen dioxide gas. Okay. Now this nitrogen dioxide gas, it is further combining with water to prepare nitric acid and residual nitrogen monoxide. Now this is possible by using a spark, which is provided by this apparatus over here. This apparatus provides the spark in this container, which you can see. There are two pipes over here which produce a spark in the container. It has been fitted in this manner, okay? And then now after some time the current is passed, okay? It is switched on, and then spark is produced in this gas jar, a closed gas jar, and then the exhaust pipe, it is put inside a bottle which contains water. Okay, now it has been put on. Okay, so there is some bubbling of the gases coming out. Okay, nitrogen monoxide is also coming out. Okay, so after quite some time, you can see the color changes slowly in this what you call bottle, which contains some water. Okay, so this has to happen for quite some time, long time. It takes quite some time. Okay, so you have to keep that in mind. So to test the gas, you have to use the acid which is from, you can use a coin, a penny coin, which is made of copper, because there will be reaction between copper and the nitric acid to produce dense white fumes. Okay, now not dense white, dense brown fumes, reddish brown fumes in color. Okay, now just have a look, have some patience. Okay, I hope all of you can see the video on your screen. Now he has placed a paper. He has placed a paper behind that gas jar, and he has plugged in the device for the power, AC power supply. It has been converted, and then now spark. Now have a look at the spark carefully. You can see the spark. Hot air is rising, and then there will be a spark, and then production of the gas, nitric acid vapors, or what you call nitrogen monoxide, nitrogen dioxide gas. It is passed through this bottle containing water for a long time. So we are learning how to prepare practically. See, you can see the spark over there, and that spark is allowing the nitrogen and the oxygen gases present in the air to combine. After combining, the gases are being made to pass through the bottle which contains water in it. Okay, now see, it was started in the daytime, now it is evening time. Now you can see the color of the gas jar, it has turned brownish. Okay, now the switch is on, is still on over there. You can see it has become reddish brown. Okay, the color of the gas jar. Okay, it is warm, it It is warm because you can feel it by the hand. Okay, so that is there. And then you can check the bottle. Okay, after some time, this liquid, which was water in the beginning, it is no more water. It has become nitric acid. Now, how to test whether it is nitric acid or not? So what we do is take a watch glass and pour this liquid, which is supposed to be nitric acid, on a jar, on a gas, what do you call a plate, watch glass plate. Put some baking soda, baking powder, and pour this liquid on baking soda. So reaction is intense. It's a spontaneous reaction, confirming that the acid which is produced is nitric acid. Okay, so that's it. Add some more acid on the watch glass, and then add some more baking powder or baking soda to it. Okay, baking soda is being added. Okay, baking soda, the formula is NaHCO3, sodium bicarbonate salt. Okay, so he's going to add it over there to the liquid, and you can see the reaction between the acid, nitric acid, and baking soda. The gas which is formed is carbon dioxide gas. Okay, the effervescence which you see on the sample, it is because of carbon dioxide gas which is coming out. So that is confirming the what do you call that the acid is nitric acid. So that is how you obtain nitric acid from the air. Okay, so that is done practically and demonstrated to all of you. Okay, so you can see this fellow is a quite very good clever fellow. By using some quickly easily available apparatus and devices, he is being able to create warm air. He is being able to create a spark in the gas jar and make the nitrogen and oxygen gases to combine and make nitrogen monoxide that combines further with oxygen to prepare reddish brown nitrogen dioxide gas, which is being made to dissolve in water and combine with some more oxygen to prepare nitric acid. Okay, nitric acid is the pure nitric acid, it is colorless. Okay, so that is how we prepare nitric acid naturally. Okay, now looking at the chemical reactions for the preparation of nitric acid, let's have a look. Okay, on the next slide. On our next slide, this nitric acid was initially known as aqua fortis. I want you all to remember this word, aqua fortis. Nitric acid was initially known as what? Aqua fortis. I want you all to remember this name, aqua fortis. Meaning, what is the meaning of aqua fortis? Aqua fortis means strong water. It means strong water. Am I clear? Can you hear me?
Sure.
Dakshish?
Yes,
Okay.
sir.
Aqua
Yes,
fortis
sir.
means strong water. Now, the next point over here is occurrence of nitric acid occurs in nature both in the free state as well as in the combined state. In the free state, we can get traces of nitric acid formed in the air during lightning discharge. Before a rainfall, we see before a thunderstorm or a rainfall, heavy rainfall, we see lot of lightning happening in the sky, high up in the sky. Now, during this lightning discharge, which is happening naturally, the gases nitrogen and oxygen, they combine to form colorless nitrogen monoxide gas. This colorless nitrogen monoxide gas, it further combines with oxygen of the atmosphere at a lower temperature, 50 degrees Celsius. Please note that during lightning discharge, the temperatures reach 3000 degrees Celsius, beyond 3000 degrees Celsius. It is at this temperature only that nitrogen and oxygen gases will combine. Now, when nitrogen dioxide has formed, which is a reddish brown gas, it is a reddish brown gas. Okay, it is mixed further with oxygen. It mixes with the atmospheric oxygen and it mixes with the acid rain to form nitric acid naturally. So these are the chemical equations which prepare nitric acid from air, and from air the gases which are required to prepare nitric acid are nitrogen gas and oxygen gas. Okay, now moving further to the next point over here. In the combined state, nitric acid occurs in the form of its salts such as calcium nitrate. Remember this, calcium nitrate. Sodium nitrate is called chili saltpeter. Sodium nitrate is called Chile saltpeter, and Bengal saltpeter is potassium nitrate. So you must learn this. Learn. In the combined state, nitric acid is present in its salts. It is present in its salts in the combined form. So you better learn these three name of the salts, their nickname as well as the chemical name. Okay. So this was the introduction to the chapter nitric acid. Now moving further to the lab preparation of nitric acid. In the chemistry lab, how are we going to prepare nitric acid? So look at the method on the screen. In the chemistry lab, normally to prepare nitric acid in over there, we take a glass retort. This is a glass retort. Okay, so it has a long neck over here, and this long neck is opening into a round bottom flask which is kept in a slanted position. And above the flask, we are allowing cold water to flow, cold water to flow above this flask so that the vapors of nitric acid can condense easily over there. Now the reaction part. Let us see the reaction part. Now in this glass retort, we place potassium nitrate salt or sodium nitrate salt. So the salts are either potassium nitrate or we can use sodium nitrate salt, NaNO3 salt. And from this cap over here, from this glass cap over here, it is made of glass. We open the cap and from here we pour concentrated sulfuric acid. Okay, and pour it over here and ignite the Bunsen burner and maintain the temperature less than equal to 200 degrees Celsius. Okay, so when these conditions are met, there is a reaction between this potassium nitrate and sodium nitrate salt with concentrated sulfuric acid, and the products obtained are potassium hydrogen sulfate or sodium hydrogen sulfate, and vapors of nitric acid is formed. So these vapors of nitric acid, they rise up, enter this long neck over here and enter the round bottom flask, and when they enter this region, because of cold water being flown over this flask, they condense in the form of nitric acid droplets and collect at the bottom of this flask. Okay, now because of high temperature, it is possible that the nitric acid which is formed, it may decompose to give nitrogen dioxide, or nitrogen dioxide plus oxygen plus water vapor. It can decompose, and after decomposition, this nitrogen dioxide can remain dissolved in this acid. It can remain dissolved in the acid. So this is nitric acid. So if it contains dissolved nitrogen dioxide, so this entire nitric acid will have a yellowish color. It will have a yellowish color due to the dissolution of nitrogen dioxide gas in this nitric acid. Otherwise, pure nitric acid is what? It is colorless acid. But the nitric acid which is obtained in the chemistry lab, it is yellowish in color. Why it is yellowish in color? Because of the dissolution of reddish brown gas, nitrogen dioxide gas in the acid over there. Okay. Now, how come this decomposition reaction is happening? Because the temperature of the reaction is responsible over here for decomposing the nitric acid. Okay. Now, it is important to maintain the temperature less than equal to 200 degrees Celsius. Otherwise, there could be wastage of fuel. This glass apparatus might break. It might break. Okay, there will be wastage of fuel. The glass apparatus might break. That is why, and moreover, instead of potassium hydrogen sulfate, potassium sulfate and sodium sulfate will be formed if the temperature rises above 200 degrees Celsius. So if these two compounds are formed in the glass apparatus over here, then what will happen? These two will stick to the glass apparatus. They will stick to the glass apparatus, and then once they are stuck to the glass apparatus, once they get stuck to the glass apparatus, they are very difficult to remove. Okay, the only last option is to throw the glass apparatus away. Next time you want to prepare nitric acid, you cannot use this glass retort anymore. That is why it is very important for us to maintain the temperature less than equal to 200 degrees Celsius during the lab preparation of nitric acid by reacting either potassium nitrate or sodium nitrate with concentrated sulfuric acid. So you must learn over here these chemical equations properly and try to remember this diagram, not to draw. Try to remember the diagram, not to draw. I'm telling you several times, do not draw and practice the diagram. Have a look at this diagram, study the diagram carefully, okay, because the diagram will be given in the examination and the questions will be based on the diagram. Okay, they will ask you, why is an all glass apparatus used over here in the lab preparation of nitric acid? They'll ask you this question also. So you must answer, you must be able to answer. And all glass apparatus is used in the lab preparation of nitric acid because in this preparation, vapors of nitric acid are formed, and vapors of nitric acid, they are highly corrosive. They react with almost anything except glass. That is why we cannot use a rubber stopper over here or a wooden stopper. If it is rubber or wooden, the nitric acid vapors will immediately react with this. Okay, that's why if you watch carefully, everything is made of glass over here. Everything, even this funnel is also glass funnel. Okay, so now this was the lab preparation of nitric acid. So you got the idea. What are the reagents required? What is the temperature?
So
What is
will
the
it react
product?
with wood? Sir, will it react with wood?
Yes.
Wood. So will it react with wood?
Why? Who told you to react with wood? We're not reacting with wood. We must not use a wooden stopper over here. We open this glass stopper and pour from here comes sulfuric acid. I am telling this entire apparatus should be made of glass. It cannot be made of anything else because nitric acid vapors react with almost everything except glass. Nitric acid vapors do not react with glass. That is why an all glass apparatus is used in the lab preparation of nitric acid. Now, moving to the next slide, the details are here. Important points to remember. In the lab preparation of nitric acid, by using potassium nitrate or sodium nitrate, we cannot use hydrochloric acid in place of sulfuric acid in the above preparation because hydrochloric acid is volatile and it cannot displace another volatile acid. That's an important point. In the lab preparation of nitric acid, all apparatus is made of glass because nitric acid vapors being highly corrosive they react with rubber or cork. The next point, the temperature in the lab preparation of nitric acid must be maintained less than or equal to 200 degrees Celsius because at higher temperatures the glass apparatus might break. Moreover, there will be wastage of fuel, and moreover, at higher temperatures, a hard crust of sodium sulfate or potassium sulfate is formed, which sticks to the glass apparatus, and it becomes difficult for us to remove that sodium or potassium sulfate. So this point becomes an important point. Okay. Now, the next point, the nitric acid prepared in the laboratory preparation, it is yellowish in color. But the pure nitric acid is a colorless liquid. Remember that. This yellow color of nitric acid is mainly due to what? Due to the dissolved nitric acid formed during the decomposition of nitric acid by heat. Because in the reaction we are using some temperature that is less than equal to 200 degrees Celsius, and that temperature is sufficient to cause the decomposition of nitric acid. So that's why the yellow color is seen from the lab which is prepared. Okay. The yellow color of nitric acid can be removed by bubbling air. You take a glass straw and bubble air. You bubble air or bubble carbon dioxide or dilute it with tap water so that yellowish color can be dissolved. Why does it dissolve? Because if you bubble air, you are bubbling what? Oxygen. If you are adding water, you are putting water over there so that any oxygen or nitrogen dioxide present in the reaction mixture, they react with each other and we get it gives back colorless nitric acid. So that was the important point to remember from the lab preparation of nitric acid. Now, moving to the next slide, we come to manufacture of nitric acid, that is the industrial method of nitric acid, which is called Ostwald's process. Which is called what? It is called Ostwald's process. Okay, now you can see on your screen there is the Ostwald's process over here. for the flowchart for the preparation of manufacture of nitric acid by the Austral's process. Now, in the Austral's process, this is a flowchart. It will help you along with the flowchart. The equations are also given. So, this Ostwald process also becomes important with respect to the equations. So, for the manufacture of nitric acid, we use dry dry ammonia gas, 1 volume, and then 10 volumes of air, because 1 volume of air contains 1 by fifth part is oxygen. Okay, that is oxygen. Okay, so that you must remember. So we mix 1 volume of ammonia with 10 volumes of dust free air and pass them through a catalytic chamber containing platinum as the catalyst, and the temperature is maintained between 700 to 800 degrees Celsius. Now remember, this is an industrial method. So by any industrial method, we prepare anything on a large scale. So in the first step, the catalytic oxidation of ammonia is happening to prepare an important product, which is nitrogen monoxide, which is colorless nitric oxide. After that, the products are sent into a heat exchanger, and then it is passed. Heat exchanger means it is lowering down the heat after the combination has taken place, and then the gases are sent into the oxidation chamber, which contains some more oxygen. This colorless nitric oxide is here. It reacts with oxygen at 50 degrees Celsius to prepare reddish brown nitrogen dioxide gas. This is reddish brown. Now, in the final step, in the absorption chamber, water is allowed to trickle from above, which is stacked, which contains in a tower quartz stone, which allows the slow movement of water from above, and from underneath, nitrogen dioxide gas and oxygen gases, they enter and combine with water, which is trickling from above to prepare nitric acid. Okay, now this is how we obtain on a large scale industrially by the Ostwald's process nitric acid. So this slide becomes important for you with respect to the chemical equations involved in the Ostwald's process. Okay, now moving to my next slide, a
Sir,
summarization. Yes.
so what is the temperature maintained in absorption chamber?
In the absorption tower, the temperature is below 50 degrees Celsius. It is normal room temperature. It is room temperature. Okay, it is very cold. It is cold over there. Okay, less than the room temperature, you can imagine. But in the catalytic combustion chamber, the temperature has to be maintained between 700 to 800 degrees Celsius. Okay, so this is just a summary over here. The critical step in nitric acid production is the catalytic combustion of ammonia, which was developed by this fellow Ostwald around the turn of the century, around somewhere 1906. Okay, that was the history, not in chemistry over here, not required. Now, ammonia combines with oxygen at this temperature in the presence of platinum catalyst to prepare colorless nitrogen monoxide gas. Okay, this gas is colorless. It is colorless gas. Okay. Now, after that, the gases are allowed to exchange heat, lower the heat, and sent to the oxidation chamber, where the temperature is maintained at 50 degrees Celsius, where the colorless nitrogen monoxide combines with oxygen gas mode to form nitrogen dioxide gas. Okay, nitrogen dioxide gas. This N2O4 means it is NO2 two molecules. Okay, now the gases are sent to the absorption tower, where water is trickling from above and some more oxygen is allowed to enter, and then we get nitric acid. Okay, so this is the summary of the Ostwald's process. So it's important for you all to go through this and try to remember the important points stepwise. Okay, now moving to our next slide, a very very important note. Nitric acid, which is manufactured by the Ostwald's process, it is concentrated to 68% by weight by boiling. Whatever nitric acid we obtain, say we obtain nitric acid in a container. Okay, the nitric acid which is obtained, it is obtained in a container. Say it is 30% nitric acid. That means 30% is molecules of nitric acid and 70% it contains water. That is called 30% nitric acid. Now, to this nitric acid in the container, I can use a Bunsen burner and warm it. I can warm it I can warm it and raise the temperature. From room temperature, I can make it higher. Okay, I can increase the temperature up to 100 degrees Celsius and boil it. Remove all the water. So when all the water has, when most of the water has been removed, we get this acid. It has been turned into 68%. Remaining 32% is water. 68% is acid molecules. Now, further concentration of nitric acid beyond 68% cannot be done by boiling. That is a wonderful thing to remember. Because it forms a constant boiling mixture. A constant boiling mixture is a mixture which boils without any change in its concentration. That means if you continue to boil nitric acid 68%, then what will happen? Beyond this 68% and beyond 121 degrees Celsius, both acid and water is lost to the atmosphere because it has become a constant boiling mixture. It has become a constant boiling mixture. So, a constant boiling mixture is a mixture which boils without any change in its concentration. Moreover, a constant boiling mixture has been given a name which is called azeotropic mixture. So, if you decide to concentrate nitric acid up to 99%, then till 68% you can boil. Beyond 68%, if you want to increase the concentration, the strength, then you cannot apply boiling. You have to apply some other method because at 68% and 121 degrees Celsius, nitric acid becomes a constant boiling mixture. So the concentration of nitric acid at 68% to 98% can be done by distilling it over concentrated sulfuric acid. So what is this called? Let me explain you by introducing a slide over here. So in this situation, what we do is we take sulfuric acid in a container like this. We kept an empty container over here. Okay, and from here we pour 68% nitric acid. We pour it on this concentrated sulfuric acid. But remember, nitric acid and strong sulfuric acid, they will never react. This is poured over here, it will flow and then it will come down like this. It will flow down. So while it is flowing over the strong sulfuric acid, this strong sulfuric acid absorbs the water content of this nitric acid from here, and when it is collected over here and try to get the strength, we find that nitric acid of 98% has been collected in this chamber over here. Okay, so this is how you concentrate nitric acid from 68% concentration to 98%. Okay, so that is what I told you in the previous slide. Okay, so concentration of nitric acid 68% to 98% nitric acid can be done by distilling it, by pouring it over concentrated sulfuric acid. This is an important point to remember. Okay, now note that in the above manufacture of higher ratio of air, in the manufacture of nitric acid by the Australis process, a higher ratio of air is required because 1/5 of the air is oxygen, and this oxygen is required in all the 3 steps of this Australis process. It is required in the catalytic chamber also, it is required in the oxidation chamber also, and it is required in the absorption tower also. Okay, so this you have to give importance to and remember these steps. Okay, now they can ask the question over here, why a higher volume of air is used? Because air contains 1/5 oxygen, and oxygen is required in the Ostwald process in all the 3 steps, in the oxidation chamber, in the catalytic chamber, as well as in the absorption tower. That is why we use a higher volume of air, okay, comparatively. Now moving to the next slide in this chapter, let us come to the physical properties of nitric acid. The first property is important. Pure nitric acid, it is a colorless acid, concentrated, while commercial nitric acid, which is prepared, okay, in the lab or in the industries, it is yellowish brown in color. That means whatever nitric acid which we prepare commercially, it has to be converted into colorless nitric acid so that it is pure, because its concentration is 98%. Okay, that is the first point. Remember this. Next point is nitric acid has an irritating choking smell. So if we inhale by chance vapors of nitric acid, that is going to cause you some irritation in your respiratory passage, and if your tongue happens to taste the vapors of nitric acid, it is sour to taste. Okay, as soon as you taste the acid, you have to go and gargle properly, otherwise it will cause some blisters on your tongue and your mouth. Okay, then you will have some mouth ulcers after that. Then you have to go to the doctor for some medication. So that's why you should avoid inhaling vapors of nitric acid. Next point, nitric acid is highly corrosive in nature. It is highly corrosive. It is non-poisonous, but okay, it stains the skin yellow. If it falls on your skin will become yellow, not black. Okay, it becomes yellow because it combines with the protein of the skin to form a yellow-colored organic compound which is called xanthoprotic acid. Because the protein of the skin reacts with nitric acid to form a complex acid which is called xanthoprotic acid, the formula of which is not required in class 10. Okay, it is not required in class 11 also, not required in class 12 also. Okay, that is sufficient. Now, nitric acid is highly soluble in water. It is highly soluble in water, and remember this, it boils at a temperature of approximately 86 degrees Celsius. Nitric acid boils at a temperature of 86 degree Celsius. Okay, now, so these were some properties. Okay, let's see the chemical properties now. The next slide. Chemical properties of nitric acid. Now, nitric acid behaves chemically in two ways: as strong acid and as well as a powerful oxidizing agent. As a strong acid in the dilute form, okay, and a powerful oxidizing agent in the concentrated form. Okay, so that is important point to remember over here. Okay, strong and oxidizing agent. These are the two properties it normally exhibits. Now we know pure nitric acid is colorless and it is unstable to heat and sunlight, and decomposes even at slight temperatures. Okay, to liberate a yellowish brown gas which is called nitrogen dioxide. Okay, here nitrogen dioxide gas, yellowish brown in color. Acidic nature. Nitric acid
Hello.
just a second.
Hello.
Just a second. Okay. Now, nitric acid which you see over here, you can see over there on the screen. Acidic nature. Nitric acid is acidic in nature. Nitric acid is a strong monobasic acid because it is capable of producing one hydrogen ion per molecule. It ionizes almost completely in aqueous solution with the production of hydrogen ion and nitrate ion, which you can see in the equation over here. So, this acidic property of nitric acid will be attributed, okay, due to the presence of hydrogen ions in the aqueous solution. So, this is the first two important properties of the acid. Okay, now moving further to our next slide, chemical properties, reaction of nitric acid with carbonates. Carbonates. When a carbonate is mixed with an acid, if you react an carbonate with nitric acid, the products formed are generally the salt, okay, carbon dioxide gas and water. Okay, this is general reaction over here. Now, water and carbon dioxide are formed because the carbonate ions react with H plus ion from the acid. Example is given over here. If you take a bluish color copper carbonate salt, okay, which is available in the chemistry lab, okay, basic copper carbonate, it is reacted with nitric acid, aqueous dilute solution. The reaction happens vigorously and the products obtain the copper nitrate, water vapor, water can be remained over there also, and carbon dioxide gas is liberated. So this observation can be seen as effervescence coming out from the reaction container or the beaker or the test tube in which the reaction is carried out. So this reaction of nitric acid dilute with carbonates becomes important for you all to remember and try to practice the chemical equation also. Now, moving to, yes.
So is that water drinkable?
So this
Or
water is in the combined form with copper nitrate, salt. So you should not drink this water because copper salts are poisonous in nature. Okay, so you have to separate this water by some suitable methods. Okay, and then that water has to be treated with the required micro and macronutrients which are essential for the human body, so that the water benefits once you drink it. So after that only you can drink the water. Otherwise, it is chemically pure water containing the elements made up of the elements hydrogen and oxygen. Am I clear now?
Yes, sir.
Okay,
Thank
wonderful,
you.
wonderful. Now moving to the next slide in this chapter with regard to the chemical properties. If you see reaction with bicarbonates over there, bicarbonates, examples of bicarbonates: calcium bicarbonate, sodium bicarbonate. When they react with dilute nitric acid, the salts obtain a salt, water, carbon dioxide. If it is a calcium bicarbonate, you get calcium nitrate. If it is a sodium bicarbonate, you get sodium nitrate, and then there is water and carbon dioxide. So remember, any carbonate or bicarbonate, when it is reacted with dilute nitric acid, where dilute nitric acid is behaving like an acid, it will produce or liberate carbon dioxide gas. It's an important thing. Which is an important thing over here. Okay, for for the chemical property of nitric acid with bicarbonates. Okay, now one more set of reactions is there. Okay, now in the next set of reaction with basic oxides and hydroxides. Basic oxides, copper oxide, zinc oxide are basic oxides, whereas hydroxide and potassium hydroxides are also basic alkaline in nature. So when they are reacted with a nitric acid dilute, they will produce the respective nitrate salt, copper nitrate or zinc nitrate or sodium nitrate or potassium nitrate, and then water is formed. Okay, so we know acid and a base will give salt plus water. This we have been knowing since class 8. So this is a general reaction happening over here for the reaction of an acid and a base. So now I think next class is your computer or your physical education or your commercial application. So I would like to stop my class here only and continue in the next class. But please hang on over there for a while before I will record your attendance digitally. Okay, so just hang on, do not leave the class. Okay, just hang on over there for some time, and then once your attendance is recorded, then I will allow you to join the other class. Okay, just wait. There are 69 participants, 68 students attending the class. Vinayak Shetri, lovely fellow. Okay, the attendance is downloaded. Now you may leave the class. Thank you so much. Have a nice day.
Thank you, sir.
Yes, sir.
Bye.